The Institute for Sustainable Futures has done a significant amount of water supply demand planning with utilities across Australia, including regional water utilities and also worldwide. I personally was involved with Rous County Council many years ago developing the first regional demand management strategy. The outcome of that work was that it was very clear that demand management, water efficiency had significant opportunities, including leakage reduction, including customer side water efficiency. Some of those options, of course, have been taken up, but there is still significant potential in the Rous region for improving water efficiency, increasing reuse, and generally improving the sustainability of water use. The key issues with water supply demand planning are to make sure that all options are considered, both supply side options, in other words, groundwater supplies, dams, desalination, potable reuse and so on, but also that demand side options are included. So in other words, those things that can permanently, structurally reduce the demand for water. So this is, and that they are all considered on an equal basis. And it's my view that this has not been done with the supply demand planning for the dam. The second thing is that we need to distinguish between drought or water security planning and long-term supply demand planning. So there's the average demand that will occur because of increase in population growth. And then there's the water security issues that arise because of a 1 in 100 year, 1 in 500 year drought. And both of these need to be planned for, but they need to be planned for in different ways. So for improving drought security, we need to look at adaptive management options, those things which can be brought on quickly in order to respond to a drought. And for long-term supply demand planning, we need to look at the large-scale application of those initiatives which reduce demand or those which can increase supply in order to close the supply demand gap. Water efficiency, in other words, saving water, reducing the demand for water permanently by structural means, is one of the largest, cheapest and quickest ways to meet the supply-demand gap in every single area that we've looked at around the world. And it's the quiet achiever. As you can see from this data from Sydney Water, it's one of the largest contributors to improving the supply-demand gap in Sydney, and it also comprises a lot of different options. This is the point of little things adding up to a lot, or pennies adding up to pounds. So the improvement of water efficiency is something that should be explored, considered in much more detail. There remains significant potential in the North Coast region for this to operate. It's also the cheapest option. So whenever we've done the analysis in different cities and towns across Australia and internationally, we found that the unit cost of water savings, of improving water efficiency, is much, much lower than supplying water, whether that's through groundwater, through intercatchment transfers, through dams or desalination or potable reuse. It's the lowest cost option and it's the one that should be explored first, but it's often considered as an afterthought and it's often considered as being something that's not significant. So this is something that we really need to change in the analysis. So we've seen, for example, in many cities and towns across Australia that, for example, in Sydney, 1 million people have been added to the population, and through the impact of a range of water saving measures, the demand has actually been kept flat. In other words, the per capita demand has significantly reduced, and we see the same occurring in other cities and towns across the world. The potential for water efficiency can probably be made more concrete by looking at an individual end use. This principle can be applied to almost any end use, whether it's washing machines, cooling towers, urinals, and so on. But if we look at the humble flush toilet, then we note that in the early 1980s, the average flush volume of toilets was about 11 or 12 litres. With the invention of the flush of the dual flush toilet, this went down immediately to 11 litres and 6 litres, or probably an average of around 8. And now the current toilets have a dual flush type of 4.5, 3 litres, and in fact the average volume is less than 4 litres per flush. And that reduction has been absolutely significant, such that we will never in Australia use as much water flushing toilets as we did in the early 1990s. And the technology continues to improve, and of course there are significant new innovations in the form of waterless urinals and similar. So this is just an illustration of what can be achieved, and if you then apply that to the front-loading washing machines, which on average use half of top-loading washing machines, and all other appliances, you can see the massive potential for improved water efficiency. So the question for the Rous region is, to what extent have we achieved saturation of best practice water efficiency across all the different uses, including industrial uses, including system leakage and losses, including all of the appliances in hotels, motels and houses and shops and factories across the region. So this is the question: what is the conservation potential for the North Coast region? I've talked a bit about the role of water efficiency in future urban water systems, and of course that will improve. It's the most significant potential that we have at the moment. But one of the questions we should ask is, what would future urban water and sewerage systems look like? We've actually inherited a system from over 100 years ago with conventional gravity sewers draining to a sewage treatment plant and then discharging either to rivers or to ocean. But if we were to redesign the system, and if we were to look to the future for a more sustainable system, then we would probably look at a more distributed arrangement, so that we would reuse wastewater closer to the source. For example, we would separate out the pollutants before they get into the system to reduce costs and to maximise the potential for resource reuse and recovery. We would also maximise all the different sources of water, whether it's rainwater, stormwater, wastewater, and use them for the best possible use available near where they're produced. And of course, we would maximise water efficiency. So this is a new, what we call fourth generation water system. There are many examples of that starting to occur. For example, at our university, at UTS near Central Station, Central Park, or the precinct around Central Park, is supplied by water from a sewage treatment plant in the basement of the large tower building. So that's an example of the fourth generation water supply, and indeed that water comes over the road or under the road across to UTS and is used in cooling towers at UTS. So this is an example of the future of urban water systems, and we don't need to be stuck in the once through use and dispose system that we currently have. I've had a close look at the proposal for the Dunoon Dam, and in my view, there are four main reasons why this dam should not be built and why alternative options should be explored. The first is that the level of service that is assumed, in other words, the rules regarding the frequency and duration of restrictions, have been changed without recourse to engaging the community. It's really important that the community have a say in what is the appropriate level of service, what are the restriction rules, relative to the very high cost of a large dam in order to meet the supply-demand gap. That measure alone, changing the level of service or the restrictions back to what they were previously or to reasonable levels, would already significantly defer the need for the dam. The second is that the impact and potential of water efficiency, improving the structural and permanent level of efficiency of water using equipment in the region, including system leakage and pressure management, has not been adequately considered. And judging by the research we've done in almost every jurisdiction across Australia, we know that there is significant potential for improved water efficiency to defer the need for augmentation. The third is that there's been no consideration of contingency options or real options, which means the ability to implement rapidly water supply and demand management opportunities during a severe drought. And with the uncertainty associated with climate change, this is probably the best way to manage the water supply system and the lowest cost in risk-weighted terms means of meeting the supply-demand gap. And the fourth reason is that the climate change assumptions are very deterministic. They're just a straight line downwards from now until 2060, and there's no consideration that in fact this is a highly variable, highly complex area, and the best way to address this is actually through contingency or adaptive planning methods. Based on the work we've done across Australia in cities and towns and also internationally, I'll put forward a series of options at a high level, which would be quite suitable for the Rous region and build on the work that I previously did in the region. So the first of those is to understand more about what water is being used and how to manage it, and smart metering is an absolutely key part of this. Leakage and pressure management is absolutely crucial. There's significant potential. There is much lower expenditure on pressure and leakage management across the region. Some constituent councils are doing better than others, but there's huge potential there. And then customer side water efficiency. So making sure that wherever it is, there is no best practice efficiency in place, that there are incentives and investment in order to ensure that happens. This is a huge opportunity for the region to grow business, to reduce the cost of business, not just water costs, it's also energy costs and greenhouse emissions, because a lot of water is used as hot water, which reduces, if we save that, it reduces greenhouse gas emissions. So there is an opportunity to create a massive employment dividend with plumbers, engineers, irrigation, landscapers, a whole range of different trades. Many more jobs will be created through a program of investment in water efficiency and in small-scale reuse and in leakage system losses and pressure management. So there is a huge opportunity for the region to put in place a comprehensive efficiency program which pays dividends across a range of different areas. The second thing is to make sure that all of the options have been adequately considered. The opportunity for non-potable reuse in particular has not been explored in the region adequately. There are plenty of opportunities for industry and commercial premises and even residential premises for this. Opportunities for contingency planning, in other words, allowing investment in short-term implementing emergency measures during the period of the worst drought on record, and also looking at a range of options that weren't considered, intercatchment transfers and so on, as contingency options themselves. The potential program which could form an alternative to Dunoon Dam, which includes water efficiency options, it includes education program, it includes reducing system losses and pressure management, would be significantly cheaper than the cost of Dunoon Dam and would push the requirement for new augmentation, whether it's Dunoon Dam or other water supply options, out past the planning horizon. So it would give plenty of breathing space, and it would put the region on the map in terms of being the most water smart region in Australia, creating employment along the way, creating opportunities for greenhouse gas reduction and for energy saving. So there are significant benefits associated with at least considering and doing the analysis to see what is possible in the region to become the most water smart region in Australia.